in this class we have to discuss about the 3D packing of constituent particles. The first way of packing packing in 3 dimension is this type of packing. See, I'll show you here. Suppose we have this molecule. We have first layer of molecules. This is the first layer of molecules. Suppose this is called as layer A. Right? Now, if we put the second layer of molecules just above the first layer, like this, second layer, and if we put third layer and fourth layer and so on, we are just simply putting the layers one after the other, one after the other, one after the other. So this type of packing is known as first type of packing. It is known as A type packing, because all the layers, they are similar to each other, right? Here, and we call it, see, this is square, so we call it 2D square packing, right? So earlier we had for this, we had done like 2D square packing for, right? So here in 3D we have this, a cube like structure is formed where just like one layer, then second, then third, then, since all the layers are similar, so we call it A type packing. Now next we have 3D type of packing from dimensional hexagonal packing. So the first way of, see, this is square packing, right? This is a square packing. Now next we have hexagonal type of packing. The first way of hexagonal type of packing is that if we are simply putting one layer, we are simply putting the second layer over the first layer. See, this green color is the second layer, and this orange color is green color is the first layer, and this orange color is the second layer. So if we are just simply putting, see, this type of packing, suppose this is first layer of molecules, right? This is first layer of molecules, and for this hexagonal type packing, we are simply putting the second layer over the first, like somewhat like this. Now this void, if we simply see this void, it is actually surrounded by 1, 2, 3 and this orange color, 4 atoms. So this is called as tetrahedral void. This is a tetrahedral void. This is a tetrahedral void. Are you getting it? These are all tetrahedral void, because this B layer, when B layer is just above the A layer, right, we get a void which is tetrahedral void. Now its name is tetrahedral because it's surrounded by 4 atoms, right? Suppose we have, like, simple try to understand like this, 1, 2 and 3, all above this we have 4th layer, so this is tetrahedral void. Similarly, I'll teach you what is octahedral void, and we'll represent it as T. Now what is octahedral void? And these are triangular, right? Can you see the triangular shapes? Now we have octahedral voids. Now for octahedral, how does octahedral voids are formed? See, suppose we have three spheres like this, and we have 3 spheres like this, just like this and this. Now can you see a gap here? Can you identify a gap made because of these 6 spheres? This gap is actually octahedral void, because these voids are made by 6 spheres. Is it clear? I'll draw it again. I'll show it to you. So see this. The tetrahedral void is due to 4. tetrahedral void is because of 4 spheres. 1, 2, see this tetrahedral. 1, 2, 3. 3 dark blue and 1 light blue. This tetrahedral is due to 3 dark blue plus 1 light blue. And if you see octahedral, this octahedral is due to 3 dark blue and 3 light blue. I'm talking about this octahedral void. This octahedral void is due to 3 dark blue and 3 light blue. So since now if an atom, you have to count, if we have, so there's one formula, if we have number of closed packed spheres, suppose if number of closed packed spheres is equals to n, then octahedral voids will also be n, and hexagonal HCP closed packing, this is HCP and this is cubic, and the packing efficiency of this HCP and CCP, it is very high, it is 74%. We have already found out the packing efficiency, and the coordination number of any atom is 12. In this case, coordination number is 12, right, for the octahedral. Here the coordination number is 12 for both the cases. Since this is a 3D structure, you can try to find it out. Now hexagonal, what is hexagonal? Hexagonal packing is such, suppose this is A layer, this is layer A, this is B. Now the third layer is kept above the second layer such that it is similar to the first layer. So this is HCP packing is actually AB type packing, and this packing is done to hide tetrahedral voids. Now this packing, CCP packing, cubic closed packing, suppose this is A, this is B, this layer is a third layer, a entirely different layer from that of A and B. Now after this third layer, we have fourth layer which will be similar to that of first layer. So this type of packing is A, B, C type packing. And here this packing is done to hide octahedral voids. I hope this much is clear to you. I know this is a little complex, that is why I have tried to explain it to you with the help of diagram so that it becomes a little easier for you, right? I think this much is enough for you.